Hello once again, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek into my personal experiences. This is a channel designed with you in mind. Let us dive into today's lesson. As we continue with our ultimate guide in organic chemistry, and we have been looking at in the previous lessons we've been looking at different types of hydrocarbons, and with the hydrocarbons we looked at alkanes, alkenes and alkynes. Now I want to bring in the topic of isomers, which is very important, one of the most important topic in your work with organic chemistry. So as you continue to study these and as your knowledge of organic chemistry gets deeper and deeper, let us look at structural isomers. Now when we are looking at structural isomers, we need to know what is an isomer. Now a structural isomer, you said an isomer, organic molecules. These are organic molecules with the same molecular formula but different structural formula. So that's the definition of an isomer. It is an organic molecule with the same molecular formula. This is the key word that you need to have whenever you're defining. You must mention the word. It is the organic formula with the same, organic molecule with the same molecular formula but different structural formula. So let me make an example here, a quick example to say how will you understand an isomer. I can have two different shapes. For example, I can have, this is a cup like this, so it is having water, and I can have a cup like this, which is also having water. Now if you look at the first cup, I'll call it A, and the other one I'll call it B. Now if you look at cup A, you can see that okay, let us suppose both of these cups, if you look at you pour in, this is 100 milliliters of water, and the other one is also 100 milliliters of water. So let's say this is water inside. Now if you look at these different cups, they have got the same volume, right? But different what? They've got the same volume but different shapes. Do you understand this simple concept? So the volume is the same, 100 mils, but the shapes are different. So that is what we mean when we're talking about an isomer. If I bring in the concept of an isomer, we are saying that the isomer has got in this part of volume, we are saying it has got the same, let me remove here. We said an isomer is a compound with the same molecular formula. So where there is the volume, it is the same molecular formula. And then where there is shapes, it is different structure, is structural formula. So even here you can see the shapes are different. Remember, the structure of the molecule is the shape of the molecule, but the volume, which is the formula, is the same. Now when we come here to say again on the definition, it is an organic molecule with the same molecular formula but different structural formula. We'll make some examples. Then there are three types of structural isomers that you need to know in your study. The first type of isomer is what? It is the chain isomer. Then we're saying, what is a chain isomer? It has got the same molecular formula. All of them, remember we said the same molecular formula, but it's got different types of chains. That's what makes it into a chain isomer. The second type of structural isomer is a positional isomer. A positional isomer, again, same molecular formula but different position of what? Of the chain, which is the side chain, of the substituents or of the functional group on the parent chain. Again, I'm going to demonstrate that to you. So we've got the positional isomer. In a positional isomer, we are saying it is an isomer with the same molecular formula. All of them have got the same molecular formula, but what is different is the positions, mainly of the functional group, sometimes of the substituent, and then sometimes of the side chain. I'll explain that. And then lastly, we've got functional isomers. Now with that, we're going to look in the next lesson on the functional groups. Now the functional isomers, it is the same, it has got the same molecular formula just like all the isomers, but it has different functional groups, which we're going to be discussing in that next lesson on different functional groups. So remember that functional isomer, it is the one which has got the same molecular formula but different functional groups. Now let me demonstrate, if not 2 or 3 on this lesson, and now discuss that. Now the first one, when we are talking about an isomer, let's look at this molecule here. And with this molecule, you can see if we are to name it, and you can see if I move from here, I move from to that, and I move to that. So this is a molecule with how many carbons? This is carbon number 1, carbon number 2, carbon number 3, and carbon number 4. So with the one with carbon number 4, remember, it is what? It is bute. And then if you look at all these is 1, if these are hydrogens, if all these white are hydrogens, how many hydrogens are here? If I'm to write the molecular formula, it's C4, and then hydrogens is H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, H10. And if you remember these, it is what? These are alkanes. Why? Because they are saturated. That's the next part. Saturated. As you can see, these are only single bonds. They are not double bonds. So now it is butane, right? So the molecular formula here, let me repeat again. The molecular formula here is what? Is equal to C4H10. Now we are calling this butane. If I then come to the second molecule that I'm given, or the second compound, now if I also do the same thing I did to say my chain here, I'm moving from this one to this one, I'm moving from this one to that one. You see, I cannot without breaking line move to that. So what I'll do on this chain, I'll look at that, and when I circle this one, we call this a branch, but we're going to explain this later. We call it a branch. Why? Because the straight line, you can see it is carbon 1, this is carbon 2, and this is carbon 3. This line is straight line, but now the other one then becomes a branch. But now if I look at the molecular formula of this one, molecular formula is equal to how many carbons? It's 1, 2, 3. Then there is another carbon, which is carbon 4. So it's C4, and then hydrogens, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are also 10 hydrogens. Now look at this compound. The molecular formula is the same. The first one is C4H10, the second one is C4H10. So the molecular formula is the same. Back to this isomer, it is a what? An organic molecule with the same molecular formula. But now something comes back to say, when we look at the structure of these molecules, if I can just expose it back again, look at the structure of these molecules. They are not the same. This molecule, as I said, if you look at the chain, it is moving straight there, there it's a zigzag, but you can see that there is no breaking of the line. But on this other one, it's much shorter. Are you seeing that? And then I said it has got that part, and we call this part a what? It has got a branch, like the branches on a tree. So now you can see that the structure is different. Now if the structure is different, it also means the name will be different. Now for the sake of this module, just for you to appreciate this, the name of this current isomer B here, the first one we said was what? Was butane. As you see this, we wrote it as butane here. Now what is the second one? The second one will be called 2-methyl propane. Now how I named it, I will say pause there for a minute. Just appreciate this concept of isomers. Don't worry with how I named this, because we are going to do what is called IUPAC naming in the later coming lessons. But for now, appreciate that the first thing about this isomer, the molecular formula is the same, C4H10, C4H10, but the structural formula is different. The moment the structural formula is different, it also means the name is different. The first one is butane, the second one is 2-methyl propane. So you see, even if you are naming them, they come up with a different name. That is what we mean by isomers. And what type of an isomer is this one? We call this molecule a chain isomer. Now why is it called a chain isomer? It is called a chain isomer because the chain is different. This one has got what? If I'm to draw it here, the first one, it is having 1, 2, 3, 4. So you've got this. That's the first one, the chain. Alright, and then that's our butane. And then if I'm to draw the second one, the chain, if you remember, it was the longest chain here without breaking is 1, 2, 3. So if I'm to draw that, I have a compound like this, 1, 2, 3, and then if you relate, it will be like this, hydrogen, and then also on the end I've got 3 hydrogens. You see this is 3 hydrogens there. So I'll also do 3 hydrogens here, and then take this now carefully. See, on the center one I've got a hydrogen at the bottom, so I'm going to put a hydrogen here at the bottom, and then I'll make it a bit longer. Then we have this particular branch that I was telling you about. Remember the branch. So this branch, you can see that it has got carbon with its own hydrogen. So it's carbon with 1, 2, 3 hydrogens. So I'm going to draw it also to say it is like you've got carbon with what? With its hydrogens. You see that? So if you look at the first one, the longest chain here is 4, and here it's carbon 1, 2, 3, 4, and the 2-methyl propane is carbon 1, 2, 3. But this part, we call it the what? We call it the branch. Are you getting that? So that's why it's called chain. Here the chain is longer, here the chain is shorter. Are you getting that? So if you look at again the naming or the definition of the chain isomer, it's the same molecular formula. What's the molecular formula? C4H10, C4H10. Those 2 compounds, but different types of chains. This is 4 carbons on the chain, and this is 3 carbons on the chain. That is what is called the chain isomer. And then the next one is called a positional isomer. I just want to demonstrate with you the positional isomers using these compounds. Now when you talk about the positional isomers, they did mention on the definition to say these are different positions of the side chain, the substituents, or the functional group. Again, Some of these I'm going to explain what are the side chains, what is what, but I want you to appreciate, for example, this compound. Look at this compound. I'm going to draw it, and if I'm to maintain a straight chain, this is carbon 1, I move to carbon 2, I move to carbon 3, I'm moving to carbon 4. I think you can see that. So I've got carbon, 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 carbon. So I'm going to draw it here to say we'll call this one A. So if we can draw compound A, this is what it looks like. Okay, so let's draw it. It's carbon, 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 and carbon. But look at the first two carbons, we've got a double bond. Are you with me? Just look at that. There is more like a double bond there with carbon, carbon. So there is that. And then when I'm drawing now my two hydrogens, as I said, it looks like that, previously that, and then the second carbon has got one hydrogen. Doesn't matter whether you put it on top or at the bottom here, it's the same. The third carbon, which is carbon number 3, it has got two hydrogens, and the last carbon has got 3. Remember, you must maintain the nature of carbon. It can only take what? A minimum of 3 and a maximum of, a minimum of 4 and a maximum of 4. So we'll call this compound, we say it is compound A. Now let's move on. Look at compound, let's call it compound B. If you look at compound B here, I'm just going to draw it on top and drag it to the other side, just so that you can see. Now look at compound B. With compound B also, I'm moving from this part, then I'm moving to the next carbon. You can see these double bonds, and then I'm moving to the part. So if I'm having these as my carbon, my carbon, my carbon, my carbon. So if I'm to draw that, I have got carbon. I know it's not clear, but I'll take it to the other side where it's clear. So it's carbon, then carbon, double bond, carbon, and then carbon. Then the first one has got 3 hydrogens, like that, and the second one has got only 1 hydrogen. Remember, the nature of carbon can take a minimum of 4 and a maximum of 4, and the last one has got what? It has got 3 hydrogens. So if I take this, it will be much clearer here. And then let's call this one our compound what? I think I dragged this too much further here. Let's call this compound B. Just leave it there. Alright, so you've got compound B here. And lastly, let's look at this one. If I look at this molecule, I'm gonna make it white here. If I look at this molecule, what do I have? I have got from here, it's a double bond, you can see that, and then I move there. This other one is special, you can see that, and this is more like a branch. See, I've got a straight chain on carbon 1, carbon 2, and carbon 3. So when I'm drawing it, I'm going to have carbon, double bond, carbon, and then I've got that, which then becomes another carbon, hydrogen, hydrogen, hydrogen. We call that the branch. Okay, then I have got the hydrogen here. Okay, let me make it like this. There's this hydrogen and that hydrogen, and this one is the one which is like this. Don't forget to maintain the nature of carbon. It can take a minimum of 4 and a maximum of 4. Now with these compounds here, we'll call this one C. So this is compound C. Now if you can now look at these compounds, and you study these compounds. Let me make this a little bit smaller now. If you can look at these compounds A, B, and C, and remember we're saying we are looking at what? Positional isomer. Let's not forget what I'm looking at, positional isomer. And what is changing here? Look at the double bond. In the first one, let's identify our double bond, the way it is moving. Look where it is. It is in the first two carbons, carbon 1 and carbon 2. In the second one, if this becomes carbon 1, carbon 2, and carbon 3, and carbon 4, this is 3 and 4. Look at the position. In the first one is between carbon 1 and carbon 2. In the B is between carbon 2 and carbon 3. And in C is between carbon 1, carbon 2. But now at the same time, the longest chain has what? The longest chain is now 3 carbons. Then what you see here, if I look at the molecular formula, the first one is going to be, calculate the number of carbons, is 4 carbons, so it's C4. Hydrogens 1, 2, 3, 4, 5, 6, 7, 8, H8. And then B, 1, 2, 3, 4, 5, 6, 7, 8. Again, B is C4, H8. And then C again is 1, 2, 3, 4, 5, 6, 7, 8. Again, there are 4 carbons because this is the fourth one. Again, it will be C4, H8. Remember the definition? Same molecular formula, C4H8 on 3 of them, but the structures are different. Now, what do we mean by the position? In actual fact, let's pause on this one. Let me give this one is no longer, we cannot say this one is more of a structural formula, because C, the structure is totally different, but the position between A and B, let's compare A and B, because that is where everything is. A and B, the position of the what? Of the functional group, they told us to say, they say it's different position of the side chain, substituent, or the functional group. So this one is more of the functional group, meaning which one is the functional group? It is this double bond. So this double bond moved from carbon 1, 2, now it's in carbon what? 2 and 3. That's what we mean now to say A and B are functional, not functional, are positional isomers. A and B are positional isomers. And what is changing here? It is the position of the double bond. Of the double bond. Are you with me? And then you might ask, what about C? C then becomes a structural isomer to A and B. Structural. So this is a structural isomer because even the shape has changed. You see, it's now the longest chain is 3 carbons. Here it was 4, so the longest chain because of the branch there. So this becomes a structural isomer. We did in the first one to say same molecular formula but different structure. In A, same molecular formula but different position of the functional group. So that is the positional isomer. If we go back, the next one is called the functional isomer. I'm not going to discuss yet this isomer, functional isomer, but what I want you to know is that when we do functional groups, we will come back to this lesson of isomers and we will bring back to say what are the 3 types of isomers, and then I will demonstrate all the 3, but more important will be the functional isomers. So guys, we've come to the end of this lesson. Now what is the next lesson? Look at the next lesson so that you will be able to flow. The next lesson is talking about what? The functional groups. You see that? After you know the functional groups, then you might be in a better position to understand a functional isomer. So join me again in the next lesson, and you cannot afford to lose out on this, because remember when we started by actually looking at the first three, where we looked at hydrocarbons, and then after looking at hydrocarbons, you were not aware, or if you are still starting, you're not aware that there were others that were following. And now this is the time for you to be able to know the other hydrocarbons beside the alkanes, the alkenes, and the alkynes. And from here, we have now to lay a foundation of different functional groups. It is very important, guys, that you are subscribed so that you can be notified as I'm bringing new lessons. Also remember, sharing is caring. Don't hide information. Share with your friends so that they can also be able to know that there is a channel that is dedicated for them. We have come to the end of our lesson. Thank you.